For the second question in our section 8.3 guided notes on one sample interval for the mean, we have the Kyoto Protocol was signed in 1997 and required countries to start reducing their carbon emissions. The protocol, probably should say, became enforceable in February 2005. The table 8.3.4 contains CO2 emissions for a random sample of 30 countries in 2010. Compute a 99% confidence interval to estimate the mean CO2 emissions for all countries in 2010. What I would like you to do is take a step back, reread the problem one more time, and enter all of your data into your calculator. I want you to work through this entire question on your own. So I want you to make sure that you are identifying your random variable and your parameter. You're verifying that you have met your 3 assumptions, which will then inform you as to which interval you should be using to create your confidence interval. From there, you will find your sample mean and the lower bound and upper bound of your confidence interval and state your conclusion. So pause the video, work on this, and when you come back, I will have the solution mapped out. When you are reviewing the solution, 1, please make sure that you have attempted this problem all the way through. It is completely okay if you make errors. That's how you're going to learn. That's how you're going to find out what you need to focus on in order to improve your skills. I also want you to have maybe a pen or a marker or something different other than the type of ink or pencil that you're working with so that you can mark out the corrections or take down any important notes that really resonate with you as you are going through the solution. And then as always, if you have questions after, please feel free to set up an appointment with me or leave a question in WAMAP. All right. Go ahead and pause the video, get to work, and when you are ready, press play, and we'll go through the solutions. Okay, so I hope that the process went pretty well for you. If you have any questions, of course, make sure that you are taking edits, taking notes, and taking any questions that you might have to ask later. So for part A, state your random variable and parameter. Because we know that we are working with quantitative, or in other words, numerical data, we're going to use x bar and mu for our random variable and parameter, respectively. So for x bar, we would say the mean CO2 emissions in metric tons per capita of 30 randomly selected countries in 2010. So a few notes here. 1, we want to make sure that we are deliberately calling out the word mean or maybe even the word average. We also want to have context, so we're talking about those CO2 emissions from those countries in 2010. But on top of that, we do want to include the unit of measure. And while it wasn't included in the narrative, the unit of measure is outlined above, as you can see in the table's title. We'll also want to note that we're working with a sample size of 30 and that these items were randomly selected. That's going to be helpful when it comes time to check your assumptions in Part B. When we move to mu, again, we can basically, instead of talking about 30 randomly selected countries, we can now say we're going to work with all countries in 2010. So coming down to your 3 assumptions, as I had mentioned before, the first item that we're going to look at is it a simple random sample? And we can confidently say yes. We don't have to assume this time because it was explicitly stated in the narrative. Then we want to come to, do we know if the population that we're working with is normally distributed, or do we have a sample size that is 30 or more? And the good news is, we know that we have 30 or more. We should check for outliers, though. So I'm going to go ahead and jump over to the calculator and talk about that with you really quickly. So for the second assumption, we wanted to note if we know if we're working with a population that's normally distributed, or if we have a sample size that is 30 or more. But it is also a good idea in this instance to check if there are outliers within that sample of 30. So we're just going to go ahead and quickly check that. So again, I've already entered my data into my data table. I can go into stat and then edit, and I have all my data here in list 2. So I just need to keep that in mind when I'm working. So from here, I'm going to go into second and y equals. I'm going to go into stat plot, I'm going to set my type to the box plot with outliers. And I'm just going to change my list to list 2. And again, in order to do that, I'm going to press the second key and the 2 key. And I now have L2. I'll go to zoom, and I want zoom stats, so option 9. And as we can see, there are no outliers here. So we are able to check this one off as having met this assumption. Okay, and now we'll go ahead and we'll talk about the third and final assumption that we need to check. Do we know the population standard deviation? In other words, do we know sigma? And in this case, no, we don't. So the best that we can do is we can calculate the standard deviation of the sample. So in other words, S. From here, because we can assume normality, because we have a large enough sample size without any outliers, and because we do not know the population standard deviation, we're going to have to use a t-interval in this case. So let's go ahead and jump back to the calculator to calculate our sample mean and our confidence interval. Okay, so we've jumped over to the calculator and we're ready to actually calculate our confidence interval. So remember, it's pretty much the same process that we've been working with in past lessons. We're going to head over to Stat. We're going to make our way over to Tests, and we want option 8, which is our t-interval. So we'll go into 8. And from here, we're going to go ahead and make sure that we have data bolded, because we are working with a list of data as opposed to being provided statistics that have already been summarized for us. In my instance, my data is located in list 2, so that's why I'm using L2 here. And then we want to make sure that our confidence level is 99%, just written in its decimal form. And again, we're getting that from the narrative that we were working with. So we are ready to calculate. And here is our result. So we've got our lower bound and our upper bound, and we also have our point estimate, or in other words, our sample statistic, or in other words, our sample mean. All right, let's go ahead and transfer this back over into our notes. Okay, so I've gone ahead and I've recorded our results from our calculator. Now it's time for us to state our conclusion in 1 or 2 complete sentences. We'll be able to do this in 1. So remember that there are 4 main components that we want to include when we are writing out our conclusion. So the first one is we want to state the confidence level that we're going to work with. So again, if you go back up to the narrative, that's going to be a 99% confidence interval. We're also going to want to include that we are specifically looking at the mean in this situation as opposed to a proportion. So we want to be clear to the reader as to which statistic we are actually looking at. From there, we also want to include context. So if we kind of are looking carefully at the notes that we've already created throughout this process, we can go back to our definition of our parameter, because it does include the mean, and then it also includes all of that context. So the CO2 emissions, it includes the unit of measure that we're working with as well, specifically for all countries from the year 2010. Lastly, we want to include, well, all that work that we had done to begin with, finding the lower bound and the upper bound of the confidence interval. So this should give us something along the lines of the following. We are 99% confident the mean CO2 emissions in metric tons per capita of all countries in 2010 is between 2.0199 and 4.8081. Now, if you decided to round some of your values from your bounds, that's completely okay. I just want you to be very careful as to where you are rounding. So, for example, do not round to the ones place. That removes way too much detail from your final conclusion, and it kind of, in my opinion, it kind of misleads the reader. So we wouldn't actually want to say it's between, like, say, 2 and 5. That's a little too generic. I would say the best bet, round your values anywhere between the 2nd decimal place or the 3rd decimal place. All right, this is our final solution. If you do have any questions, feel free to let me know.